Hello and welcome to all. In today's lecture, we are going to cover what do you mean by ambiguous grammar and how to remove the ambiguity from the given grammar. So here, ambiguity in the given grammar and language, the parse tree has to be unique even though the derivation is leftmost or rightmost. Means whenever we are going to draw the parse tree for the given grammar, okay, or for the given string with the help of given grammar, then the parse tree there must be a unique parse tree, or there must be only one parse, leftmost parse tree or rightmost parse tree. If it is possible to draw more than one parse tree, more than two leftmost parse tree as well as or rightmost parse tree, then we are going to say that the given grammar is ambiguous grammar. So ambiguous grammar, if there exists more than one parse tree for a given grammar, that means if there is more than one leftmost or rightmost derivation possible, then the given grammar is said to be ambiguous grammar. One more concept related to the ambiguity of the grammar is inherent ambiguity. A CFG is called as inherently ambiguous if all the production rule in the given grammar is ambiguous one. Means in the given grammar, suppose 4 production rules are there and all those production rules are ambiguous one, then we are going to say that grammar is inherent ambiguous grammar. Now how to remove the ambiguity from the given grammar? So here most of the control structure such as if, for, while, switch and expression like arithmetic, logical expression, bitwise expression can be generated by context-free grammar, but many times resultant grammar is ambiguous one. So for whenever we want to design a compiler, or for a compiler we need an unambiguous grammar so that it generates correct translation of the source program. The concept here, whenever we want to remove the ambiguity, the concept of associativity and precedence are used in a compiler design to remove such ambiguity. And one more, to remove the ambiguity from the given grammar, we have to introduce new variable or new non-terminal in the production of the given grammar. So here we'll see one grammar here, e equal to e plus. So this one is given grammar. Is it ambiguous or not? Actually it is ambiguous one, but I'll take one example. Suppose we want to generate the string with the help of above grammar is id plus id into id plus id star id. This string we want to generate with the help of above grammar. Then how to generate it? So here you can see, first we know that whenever we want to generate the derivation of the string or with the help of given grammar, then we need to start with starting variable. So starting variable having total 3 plus 3, 6 productions are there. So I am going to take, suppose e tends to e plus e. So first of all I am going to take e tends to e plus e. After that I am going to replace this e, okay, first e with, let us say, id, okay, first e with id. After that e, I am going to replace this e with e star and finally I am going to replace all these e with id, means terminals. So we are going to generate the string which we want to generate with the help of our given grammar. So this string is generated id plus star id plus id into star id. So same string I can generate with the help of another way. Instead of taking e tends to e plus e, I can start it with e tends to e star e. Instead of that I can take the first production as e tends to e star e. Okay, and after that I am going to replace this first e with e plus e. Okay, and finally I am going to replace all these e with id. So again with the help of this production also I can generate the given string, means id plus id into id star id plus id into id. So with the help of two way it's possible to generate the same string. That's why the given grammar is ambiguous one, and we have to remove the ambiguity from the above grammar. Then how to remove the ambiguity from the above grammar? For that, to remove the ambiguity from the given grammar, we have to introduce some new variables, as well as we have to check the priority and precedence of the given operator. Okay, so the given grammar is this one. So what I'll do? So here there are total operators are plus, star, minus, slash, and rest to 5 operators are there. Plus, star, minus, and slash as well as raise to. So here plus and minus having lowest precedence or lowest priority, sorry, and star and slash having next priority and raise to having highest priority. So the operator which having less priority, okay, the operator which having lowest priority should be closer to the starting variable, and the operator which having highest priority will be away from the starting variable. So here plus and minus having the lowest priority, so I am going to take E tends to E. Okay, E tends to E plus, as well as I need to introduce some new variable to remove the ambiguity. So I am going to introduce new variable E tends to E plus T, and this variable should appear on its right side. Why? Because this operator is the left associative. Okay, so that's why this operator should appear on its right side, as well as E minus T, because plus and minus having the same priority. Okay, that's why it is on it is closer to the starting variable as well as on same level, and there must be a path from newly introduced variable from the starting variable. That's why E tends to T. This production we need to add it. After that, next production is, sorry, next operator is star. So T tends to T star. Okay, again I need to introduce new variable. Let us say F, and here you again star and slash, which having the that two are the left associative. So that's why T star F as well as T or F, that production I need to add it. As well as there must be a path from T to F, so that that production I am going to add in here. After that, raise to operator. So F tends to, okay, this raise to operator is right associative, so newly introduced variable should appear on its right side. Okay, so let us say I am going to introduce new variable as G, and this variable with the help of that we are generating production, that will be on right side, G or F, and there must be a path from F to G, and finally G to ID, this production will be added. So this all production which is free from ambiguous grammar. This grammar is does not contain the ambiguity. So here you can see in this slide we have generated the grammar which is free from ambiguity, or this grammar is an ambiguous one. Thank you.